Right, I will share my screen now so that we can start.
Yes,
if it's
sir.
not sharing, let me know so that I'm aware that the screen is not sharing. All right. What are you seeing on the screen?
Nothing yet, sir.
Nothing yet.
Yes, sir.
How about now?
Still nothing, sir.
Anything?
No, sir.
There's nothing which I see on the screen.
No, sir.
How about now? Nothing?
Still nothing, sir.
No, nothing. Nothing?
No, sir.
All right, so maybe let me try to log in again. How about now? Hello?
Still nothing, sir.
Nothing.
Yes, sir.
But here it's saying
Yes, sir.
the screen is showing. On my side, it's even saying it's showing.
Oh, on my side, it's still loading.
What is loading?
It's saying screen loading on my side.
Or it's saying screen loading?
Yes, it's now fine, sir.
Okay.
Yes, sir.
Is it clear?
Oh, it's still stuck on the Teams app, sir.
What is it saying?
It's just showing the circle with my initials.
But the screen is not showing.
Yes, sir.
Anything?
Nothing, sir. It's just showing your initials.
Hmm. I'm trying to find out what could be the reason why it's not opening. So just be patient a bit. It's still showing the initial nothing as well.
Yes, it's now fine.
It's now fine.
Yes, sir.
All right. Let's see. What are you seeing now?
Yes, sir. I'm seeing a red wallpaper.
Red.
Yes, it's now fine.
Okay. All right. So these are circuits that you sent me yesterday, electricity and magnetism. Is that correct?
Yes, sir.
Yes. So let's just discuss the basics for electricity. So this is a circuit, electric circuit. It has components. That V, what is the V which you are looking at there? What does it mean, that V?
Voltmeter.
The voltmeter, yes, the voltmeter. What does a voltmeter measure?
The potential difference.
Another word for potential difference, which you can replace potential difference, is what? Another word for
Um,
potential difference is what? Another word for potential difference. You can call it to measure potential difference or what? A voltmeter measures potential difference or what? Hello?
Yes, sir.
Potential difference, or what we call voltage.
Oh, voltage.
So another word for potential difference is voltage. Voltage is measured by a voltmeter. That is the component which is represented by the letter.
Say I'm receiving a phone call. Say I'm receiving a phone call. May I please quickly answer it?
All right.
Yes, sir, I'm back.
All right. So we're saying the component voltage is measured in volts. That is why the units are volts with just a letter V. Okay.
Yes. Yes, sir.
Yes. So on that volt, on that diagram which is on the left, this is the diagram which you are talking about. How does current move? So there is a line that is given, the long one and short. Long one and short. What do these lines mean? The long one, what is the polarity? Is it positive or negative?
Positive.
It's positive. Then that one negative. Then we have positive, negative. So electricity, when it's moving, always starts to move from where?
From the
When
left.
we don't say from the left, but from which terminal to which terminal? When electricity starts to flow, it starts to flow from which direction?
From the left.
They should be positive and negative. So you must tell me,
Or from the positive side. Positive terminal
going to which terminal?
to the negative.
Yes. So your arrows, in other words, they are going this direction. They go in this direction until comes back to the
Don't they
negative.
go from the positive to the negative?
Yes, that is correct. So this is the positive side, the long one. This is the negative side,
Oh, yes.
which is short. This is negative side, which is
Yes.
short. So always current, when it starts moving, moves from the positive, then it flows. It flows, facing that direction until it comes back to where it started from, which is the negative. That's how current moves. Okay.
Yes, sir. Yes, sir.
And why are they saying this is series and this is parallel? What is the difference there?
In a series circuit, there's only one pathway for the electric current to flow, but on the parallel side, there are more than one
Pathway.
pathways for electric current to pass.
Yes, yeah, correct. So in other words, on our diagram, the only pathway we said current will start moving from left. I mean from the positive. You don't say left, always from positive. That is positive, this is negative
Yes, sir.
side. So when current is moving, always start at the battery there, start to move in this direction. Then it comes. So the pathway, it will only come through the resistor, through that resistor, and then comes back to the battery. So which means that pathway is only one. So when there's one pathway, which means the circuit is connected in series.
Yes.
But if there are many pathways in which current can flow, that circuit is parallel. For example, this one, it has many pathways. When electricity starts flowing from the positive, comes here, from the positive, then when it reaches this point, we call it a junction. This point, we call it a junction. Why do you call it a junction or a node? We call it a node or it's a junction. That's where current now split, which means it has many pathways. So from that node or the junction, call it a junction or a node. Are we still together?
Yes, sir.
So at that junction or the node, that is the one which I circled here. Current has many pathways. Either it can go this way or it can go this way, some current will go the three pathways. That indicates that this circuit is not in series, but it's in what? Parallel.
Parallel.
So once the current flows in this way, the other one this way, and then the other current this way, it will also come together at this node. It's a node, this one. It will join again. So here it's going to split to break down. Here is now building up. Then now it's the same current that is flowing. Then it comes back. That's how it moves. So first it comes, when it reaches this junction or a node, it splits. Some current goes through the first resistor and the second resistor. It only split twice because that voltage
Yes,
is
sir.
just measuring the voltage across the resistors. And then it comes back to where it started from here. Okay. So that is what I was just explaining so that you
Yes,
just
sir.
know the concepts talking about. Right. So let's move on.
Yes, sir.
All right. So when they were measuring voltage, for example, here, you are seeing there's V1 and V2. Can you see V1 and V2?
Yes, sir.
Yes. Let me just. V1 and V2. What are they measuring, those V1 and V2? If you can explain to me.
The voltage.
Across each resistor. They are measuring voltage across each
Yes, sir.
resistor. Yes. So V1 is measuring voltmeter at the first resistor. V2 is measuring voltage at the second resistor. And then that VT is
Yes.
measuring the VT. What is that VT?
The overall voltage.
Yes. So in other words, what they mean there is that this voltage is the same with this one. These two voltages are equal in size because they are all measuring voltage across the resistors. So those voltages are equal.
Yes, sir.
That's what you must know when solving circuits. And also the reading at this voltmeter is the same as the reading at this voltmeter, and is the same as the reading at this voltmeter, which is the same as that, because they are in parallel.
Yes, sir.
Are we together? Yes. So take note of that. To get to master this when you are doing some problems that are going to involve calculations. All right, so that's why all the voltages are voltage in parallel across battery is the same as 3 volts for parallel side. So everything on the right is 3 volts, 3 volts, 3 volts. What about the one for the left? What will be V1 and what will be V2? Hello?
Yes, sir.
What is going to be the value of V1 in our case? Yeah. What will be the reading? Here we found that V1 and V2, this is 3 volts, equals to 3 volts. And this one is equals to how many volts? 3 volts.
3 volts.
And then this one is also equals to how many volts? 3 volts.
3
Why?
volts.
Because, yes, why is it? Because all the resistors are in parallel. So that's why all
Parallel.
the readings are just the same. What about here? What is the reading at V1? We said V total is equals to 3. What about V2 is equals to 1? And V1 is equals to 1.
Uh, V2 is equals to 2 volts, and then V1 is equals to 1 volt.
Why? What is the reason?
Because the V2
Because of what? That one you can use it to calculate and justify, but what is important is just to know that if you said V2, you said it's how many volts V2? Hello?
2 volts. It's the
V2,
network.
oh, it's the network. V2, you said how many volts? 2 volts. Hello?
The network, I cannot see. It's cutting.
Oh, it's cutting. What are you seeing now?
2 volts.
Are you seeing the screen?
Yes, sir.
All right. I was asking what about V2 is how many volts?
It's 5. Yes, sir.
All right. V2, how many volts?
2 volts.
Or you said 2 volts. And then V1?
1 volt.
1 volt. So what is important is that these two, they add up to this sum. This is the sum. That is what is important. It can be 1,5, 1,5 volts, 1,5, 1,5, as long they
Yes,
are
sir.
adding to 2. But when we are going to do calculations, that's when they will see. But what is important that at the end of the day, they must give you a total of 2. I mean, of 3 volts. Okay.
3 volts. Yes, sir. Yes, sir.
So these are just the basics which we're discussing here. And then they gave you an example. They are saying the following voltmeter reading are taken in series. So If it's in series, they are saying V1 is 2 volts, V2 is 4 volts, V3 is 2 volts. What is the reading on V4 and V total? So what are we going to do here?
Can I please quickly write it down?
All right.
Yes, sir.
Yes. So we're told that V1 is how much? 2, V2 is 4, V3 is 3. So we have 2, 4, and 3.
The network is cutting.
All right. I can hear it, but we'll try to just manage for today. Isn't it because of load shedding? You find out some places the boosters are not working now. All right. So let's calculate.
Oh,
What is V4 and what is V total? V4
is equals to V1 plus V2 plus V3.
which is how many volts?
8 volts.
8 volts. That's correct. 8 volts. And then V total at the top here. What is V total?
8 volts.
Also 8 volts. Because that voltmeter is parallel to the V total. So they are all the same. They are the same.
Yes, sir.
Okay. Yes. All right. So here we are having the basics. I can see you have mastered them, but you need a question which I will send, which you work on, then we'll discuss it tomorrow. All right. So
Yes, sir.
another way of calculating voltage. Voltage has many formulas. Either you can use at the back of your question paper, there are formula sheets. If you are given voltage, resistance, voltage is equal to resistance times what? Times current. You get it?
Oh, yes.
Yes. So another way of manipulating all these things, you know voltage is equal to resistance times current. Voltage is equals to resistance times what? Times current, I. Now,
Yes, sir.
yes, let's say you want a resistance. Let's say you want resistance. You make R a subject of the formula. In other words, you say R resistance is equals to voltage over what?
Over
Over
I.
current. Yes, you do the same. If you want I, you say I is also equals to what? That's
V
your
over
maths
R.
V over R. That's when you use your subject of the formula, your mathematics comes in now. V over R. That's why when we come to this formula, voltage is equals to resistance times current. And at the same time, you can also write that voltage is equals to what is resistance? This is the R. So you write R. Current can also be written as what? V over what? over R.
V over.
Yes.
Yes, sir.
So, in other words, you are just manipulating these things. Then we are having many formulas for voltage is equals to I squared R. Does it give you the same? And there's another
No, sir.
formula for which gives us I squared R, its power. Let me check. These ones, they are cancelling. They just give us V is equals to V. It's not the one which I want. The one which I wanted to tell you is power. Power is equals to what? Voltage.
Yeah, sir.
You have not. Hello?
Yes, sir. We haven't learned about power just yet, so I don't know the formula.
All right. So I will leave you for you to research on power and also the formulas for voltage, which is equals to resistance times current. This one you must know it already, okay?
Yes, sir.
You must know these formulas. But however you are given these formulas in the question paper, they will be there at the back of your question paper in case you have forgotten. But anyway, let's go to the question. It's saying how much energy is transferred when a 60-volt source, this is the charge, coulombs, flow through a conductor. A conductor which they are talking about is any material that can allow electricity to pass through. That is a conductor. Any material that can allow electricity to pass.
True.
Yeah, it's a conductor. So that is the formula which will be given at the back of your question paper. But make sure that you are using SI units when you substitute. SI
Units.
when you are given kilovolts, you convert them to volts. When you are given nanocoulombs, make sure you convert them to what? To coulombs. Okay?
Yes. Yes, sir.
When you are given nanocoulombs, like I indicated there, or micro coulombs, which means nano, we are going to multiply times 10 to the power negative 9 coulombs.
9.
Then if it's micro, you are going to multiply times 10 to the power negative 6 to convert it. Then it becomes coulombs. So you are only changing this
Yes, sir.
n by multiplying by that. So volts, if you are given kilovolts, then you must change to the SI units, which are the volts. So this one,
Yes.
yes. And when you are done, when they ask you energy, don't forget to put the unit, which is the what?
Joules.
The J. That is the SI unit for energy. That's all. So I will send another question just for you to warm up for the physical science. But as far as I can
Yes,
see,
sir.
so here is just a matter of substituting using your mathematics. Where there is V, you just put 60. And when you are substituting numbers, don't put the units. Don't say like you come and do like this. You say 60 V is equals to W over 6C. Don't put the units like this. Just use the numbers only. Since
We
you
use
want
the
to find,
units at the end.
you use the units at the end. You get it? Yes. You use the
Yes,
units
sir.
at the end. Yes. So that's what you must do. Don't put it on the calculations because it will confuse. After you're done, know that W is measured in joules, which is your energy.
Yes, sir.
Any questions here, or I will have to give you a question paper where you work. where it is having a question for electricity.
Yes, sir. Can you please send it?
All right. And also the thing which you must know, for point charges, coulombs, we said the field lines for positive, negative. If it was a battery, it would be long line and short line for negative. Electricity always move from positive towards the what?
To the negative terminal.
Yes. So the arrow is like this, going this direction, coming towards the what? Negative. It's coming from the idea when you put 2-point charges, when they say draw field lines, these are the field lines, always away from the positive, always away from the positive, towards the negative. So these are the
Yes,
field
sir.
lines, yes, towards the negative, but away from the positive, away from the positive. So whenever you are told to draw the field lines of any two given point charges, positive charge, negative charge, always the arrows, they go away from the positive. The same way electricity flows, away from the positive terminal, going towards the what?
Negative terminal.
Yes. So these are field lines. This is how current is moving towards the negative. So
Yes,
always
sir.
when current starts from this positive side, then it starts to flow. Okay.
Yes, sir.
So I'll send a question for physical science about this. Let's go to mathematics, which you sent here, where we are given this alpha, these are our coordinates. And on your diagram, they said you must know quadrants. These are quadrants which you are given here. What do you understand by these quadrants? Quadrant number 1, quadrant number 2, quadrant number 3. Anything that you know about this quadrant?
Not yet, sir.
All right, let me give you. So we normally say these quadrants, they follow what we call cast. Like we call it cast diagram. Must know it by heart. Cast. What does that mean? It means any angle which I'm going to find in this quadrant, if this is alpha, tan alpha, sine alpha, A is representing that all trig functions, sine, cos, and sine. I mean sine, cos, and tan, they will be positive. All of them, they are positive. Positive. All. Yes.
Yes.
And then in this quadrant number 2, only sine, S, that's why there's an S here. Only sine is what? Positive. Which means quadrant number 2, for example, the angle beta. This beta which we are having here, it's in quadrant number 2, this one. When I was in quadrant number 1, I'll be having an angle like this. With here where this angle is alpha. It's an acute angle. What is an acute
Yes.
angle?
Angle less than 90 degrees.
Yes. When your alpha is acute, it means all the trig functions for sine alpha, tan alpha, they are all positive. That's why we are using that all trig functions, all trig functions, they are positive. All trig functions are what? Positive. But in this quadrant, where now the angle is now beta. So the angle is now beta, meaning that the angle is a bit bigger. So my quadrant now, it's in this quadrant number 2. We call it quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. We always move in anti-clockwise direction, starting from the origin. we move anti-clockwise in this direction. Anti-clockwise. That's how we move. So our 0 is here. Then you go 90 anti-clockwise. Then we come what? 180. Then we come 270. Then lastly, 360. You come to the original. It is here. Okay?
Yes, sir.
Yes. So what are they saying about these quadrants? They are saying only sign is positive. For example, sign of beta. We are still considering this angle. The one they are calling beta it's outside. It's outside here. But you can still refer it as this beta, which they are referring to inside. As long you want to calculate your trig functions. Sine beta, that is the angle. What is sine? Which means opposite of beta. There is y. That is the y. Opposite over
sir.
hypotenuse. Your hypotenuse is the r. So it's y over r. But that y over r is positive. That's what we are saying. So y over r has to be positive. Why? Because it's quadrant number 2. Yes. Only sign is positive. If we are saying in quadrant number 2, only sign is what? Positive. Check now when you go to cos. Cos, it says adjacent over hypotenuse. So it's x over r. But we said in this quadrant, only sign is what? Positive. So which means I must make that x a negative. That's why the answer is x over r. You do the same for tan. Tan beta is y over x. But because tan in that quadrant, we said only sign is positive. Either you can put the negative on top, or you can put the negative at the what?
Bottom.
It's still the same. Minus 1 over 1 or 1 over negative 1 is still what? Negative. So whether you want to put the negative here or you want to put the negative down, it does not change the value. Okay?
Yes. Yes.
At the end of the day, you have multiplied by a negative. That's why I was saying it's a cast diagram. They call it cast diagram. Why? Because they are simply saying all trig ratios are positive. In this quadrant, only sign is positive. In this quadrant, only tan is positive. In quadrant number 4, cos is positive. That's why the diagram, they call it cast diagram. Cos, only cos positive here. All trig functions are positive. Only sine, only tan. Then that is your trig diagram is done. Any questions there?
No, sir.
Yes, but you need to practice with the questions. So, yes, so that you get the logic. But for now, you are knowing what a cast diagram is. It looks like this. You write your C, your A, S, and T. So what do they mean? You are just rotating the triangle. If it's in quadrant number 3, so this is quadrant number always 1, start from there, quadrant 2, quadrant 3, quadrant 4. If you are to draw a triangle in quadrant 4, it will look like this. Then your beta, it will be here to there. Then now, can you see the angle is increasing?
Yes, sir.
But I said you can, and the 90 degrees is there. You can still say this is your x, This is your Y, and then this is your R. So if you are looking for sine, you say sine beta. What is sine beta here? Sine beta will be what? In this triangle.
Y over R.
Sine beta is going to be Y over.
Y over R. Y over R.
Yes, you are right.
R.
But we said sine only tan is positive in this quadrant. So after you say Y over what? R, what must you do? Hmm?
We have to use the cosine.
The cast diagram, this one. We said in this quadrant, number 3, this is the quadrant number 3.
Oh.
Only tan is positive. So you have found that sine beta is Y over R. Then you must add a negative to make it minus. Because it's not a tan, it's a what? It's a sine. What about cos of beta? Yeah, it will be what?
Negative X over R.
Yes. Then what about tan beta will be what?
Y over negative X.
Tan is positive in that quadrant. We are
It's
just
Y over X.
to be just Y over X, yes. We are done. So once you know the cast diagram, you are done. You'll be just knowing, there's no problem. Let me just calculate the way I calculate. I will put the sign after I've done calculating. So first calculate what is the value of tan. Ignore the signs. You only come with the signs after you have found your value. Then you say, but in this quadrant, sign is positive only. Only tan. Only all of them, they are positive in that quadrant. So if you are drawing a quadrant in quadrant number 3, let's go to draw a triangle in quadrant number 4 now. We are done in quadrant in triangle number 3. Let's put our angle. It's a triangle in quadrant number 4. Now we are having an angle like this, 90 degrees there, like that. Then this is your X, this is your Y, and then this is the R. Then this is the angle beta coming to here. You know your diagram cast, it's like this. What is sine beta in that quadrant? What is sine beta in this quadrant?
Yeah, please just quickly write it down.
Okay. What is sine beta in that quadrant?
I'm still writing it down.
Calculate sine beta, tan beta, and cos beta. So that
All of them.
yes, in this quadrant number 4. So whenever I see a triangle in that quadrant, know it's number 4. When you see a quadrant here, you know it's number 3. Here, quadrant number 2, quadrant number 1. Now we're in quadrant number 4. So quadrant number 4, only cos is positive. Others are negative. We are done. That's how we use this cast diagram. So calculate what? Let's start with what? Sine. Sine beta. Sine beta is what? Opposite over.
Hypotenuse.
That's what you do, which is what over what?
Oh,
Is equal to? From our diagram here, what is sine? This is the angle beta. And I told you beta is outside. You can also put it inside like that. So what is sine beta?
R over Y.
No. R is not the opposite. R is not the opposite. Opposite beta. The side that is opposite, this side. So why are you saying R? Is R opposite to beta? Which side is opposite to beta?
Oh,
Huh?
Y.
So what has changed? And what is the hypotenuse?
R.
Y over R. Then you come to your diagram. It's saying only cos is positive and others are negative. So what must I do to this Y over R?
You should put the negative.
Yes, either you put a negative on the negative one. So it will be minus Y over R. That's all. We are done. Let's go to
Yes.
cos beta. Cos beta will be equals to what? Adjacent.
Negative X.
Before you go to negative X, please, let's put the trig ratios without the signs. Cos beta is what over what? In our diagram here, what is the adjacent? The adjacent?
X.
Yes, it's X. And what is the hypotenuse?
R.
R. But the rule is saying in this quadrant, only cos is positive. So this is only a positive X. Why are you putting a negative? Because it's saying in this quadrant, only cos is positive. So where is the negative which you wanted to put coming? Why did you want to put a negative? Negative, you are getting it from what? Because in that quadrant, the rule says only cos. C, cos is what? Positive. In this quadrant, all of them are what? Positive. In this quadrant,
Positive.
only sign is positive. In quadrant number 3, only tan is positive. Okay. So let's do the last one.
Yes.
Tan beta is what? What is tan beta?
Y over X.
Y over X. Yes. Let's deal with the sign. What about the sign?
We remove the negative X.
It's Y over X. What is the sign? I'm asking. Tan beta is equals to Y over X. Yes. We want to know the sign. Is it positive or is it negative in that quadrant? Tan.
Over
Over? Hello?
it, yes, it's over X.
So what is the answer? Is it Y over X or it's negative?
It's Y over X.
So is tan positive in that quadrant?
No, sir.
So what is the answer?
Y over negative X.
Yes, you can say Y over negative X, or you can say minus Y over X. It's still the same. But I must see the negative somewhere. because only cos is positive. That's why
Positive. Yes, sir.
we are talking of tan. So I must see a what? A minus. If I'm talking of sine, also in that quadrant, I must see also a what? A minus. That's why here it was negative y for sine. For tan, there must be a negative. Only for cos, C, cos. That's why it's a what? Positive there. Positive. Only for cos.
Yes, sir.
Yes. So we must master those things. When you are done finding, don't rush to say it's negative. What? First, put the trig ratio. When you are done, use the diagram to determine the sign which you are supposed to put. Okay?
Yes, sir. Yes, sir.
So I will give you some questions so that you practice. So
Yes.
that's the end for today. We'll continue tomorrow. Any
Thank
question?
you, sir.
All right. So
Thank you so much, sir.
Okay.
Thank you so much.